Hello, Susie and George. We have a really weird layout I will fix in a moment. Can you guys say something so I can check your audio? Susie, they can't hear me. I am muted to them. Hi, sorry, I didn't mean to mute myself to you. I clicked the wrong button muting my video. Susie, can you say something so we can do an audio check?
Hi, everybody. Can you hear me?
Yep, just fine. George?
Okay, I think I just unmuted, right?
Yep.
Yay.
So I'm going to let Susie take over the stream. I'm going to make you guys look all pretty. You look pretty already. Your layout does not look pretty. I'm going to make your layout look pretty. And then we're going to clean some things up around here. And Susie's going to be hosting the channel for the next 2 hours. But don't worry, we'll be around here to take care of things in the background. But for now, I'm going to say so long, farewell, and thank you for all the bits, but don't be afraid to send some more and send your friends our way. Bye-bye.
Hi, everybody. It's producer Susie back, and now I am here with George Kramer from PSI. And George, why don't you tell us a little bit about what you do at the Planetary Science Institute and what you do elsewhere?
So I am a professional lunatic. I study the moon almost exclusively, and I study it using, these days I use spectroscopy in the ultraviolet, invisible, and near infrared wavelengths of light. And I use that to understand the composition of the surface and maybe what's going on underneath, inference from that, and also to study how the surface of the moon is interacting with the entire space environment, like from meteorites to the solar wind.
All kinds of cool stuff like that.
Yeah.
That's pretty amazing. So what is your favorite thing right now about studying the moon? What is your favorite thing to kind of pay attention to that most people probably don't know?
So there's actually two things. So one thing that I get really excited about are lunar swirls. They're called lunar swirls because usually they have a swirly light pattern. They have a bright feature. We say that they're high albedo, meaning they reflect a lot of light back. And they look like they're really freshly made, but it appears to actually just be an illusion that they're freshly made. And the other thing is that every time we see a lunar swirl, it's associated with what we call a magnetic anomaly. The moon doesn't have a magnetic field the way that the Earth does, or Mercury, but there are these like discrete locations on the moon where there's a magnetic field, as if somebody threw a bunch of bar magnets down under the crust or something. And we see swirls in most of those locations. The other thing is the water that we're finding on the moon, and in particular, I'm interested in the water we find on the moon. So some people have been studying samples that show evidence that there was water inside the moon, maybe in some of the last places where volcanic eruptions occurred. But I'm actually interested in this phenomenon where the water is created sort of like as a really thin layer, or like a monolayer, maybe even just a couple molecules deep. And it's right now it's a little bit unclear whether we're looking at H2O or just OH. But what's cool about it is that we see it kind of be created and destroyed with the day-night cycle on the moon, especially in the latitudes between 30 and -30, like the equatorial kind of latitudes. And then as you go to higher latitudes, going towards both poles, it seems to not be destroyed as often. So it just kind of sticks around a little bit as you go closer and closer to the poles.
That's pretty interesting because you don't expect it to have that different a climate because
Right.
because there's no atmosphere on the moon.
Right.
Yeah. And getting back to those lunar swirls, those kind of things on Earth would be created by like wind and stuff, but the moon doesn't have any of that. So how interesting that they could be created by magnetic anomalies.
Right. Yeah. And actually, so I like to kind of make the analogy well, let me back up a little. So it looks like the lunar swirls are actually somewhat ironically, not created by the solar wind, but because of the solar wind. So the solar wind, it's just particles that the sun is throwing at the entire solar system. And on the moon that doesn't have an atmosphere or a magnetic field to deflect these particles, will actually interact with the soil and darken it and change its composition to some extent. But where there's lunar swirls, where there's these magnetic anomalies, it seems that these magnetic anomalies are creating electric fields, and those are actually deflecting the positively charged particles away from the surface so that they can't get to the surface and darken it. So they wind up continuing to look bright. So my analogy is if you put suntan lotion on your skin and you made a swirly pattern, and then you're soaking in the sun, and the part where the sun can't go is what remains bright. If you start off with bright skin, of course.
That's a good anomaly, because a good explanation of that, because it kind of helps it all make sense with how the pattern will turn up.
Yeah.
Have you noticed that there tend to be more of those kind of anomalies on the far side of the moon? Because I know that often when we are looking at images and stuff of it, that side tends to be darker.
Right. So the far side of the moon, actually, I would say that the near side is overall darker because it has a lot more Mare basalts, which are really dark. But on the far side, there is the South Pole Lake Basin, which is a little bit darker. But actually, it's a great question because, yes, most of the magnetic anomalies are on the far side of the moon. And they're up in South Pole Lake Basin, which takes up about, if you looked at the far side of the moon, it's taken up the bottom. Let me try this again. That one basin, if you drew its topmost point, would get to about the center of the moon, and the bottommost point is at the South Pole. And then you kind of draw a circle there. And most of the magnetic anomalies are in that kind of top half portion. And it's not known why. I'm actually somewhat a fan of this paper that came out in, I think it was 2012 or 2014 by Mark Rozorik, who he thought that maybe it could be from a differentiated meteor, differentiated planetary body that had been broken up. And so the iron core comes at the far side of the moon and smacks itself in there and left behind all of this magnetically charged iron that we can't see at the surface, but
would that have been at the creation of the moon or something that happened after?
Happened after. And I think that he's even associating it with the creation of South Pole Lake, although I might have that part wrong in my head.
That's okay. You're dealing with a producer here, so I'm not this most scientifically knowledgeable, but I am a big fan of science, so I'm trying to ask really good questions.
Well, you're doing yeah. Don't stump me. Oh my gosh.
I try not to, I promise. What do you think would be one of the things that people generally don't know about the moon, but that you found kind of the most fascinating?
It's the lunar swirls, actually.
That's really cool.
Yeah. Whenever I give a talk about them, I always ask people okay, how many people in this audience, have heard of lunar swirls? And I tell them, hey, don't worry, because if you're not a lunar scientist, you probably haven't. I mean, even other planetary scientists, a Martian scientist or somebody who does atmospheres on Jupiter and Saturn or something, they've very likely never heard of lunar swirls.
How recently were they discovered?
So I think it was 1966 with some of the first images that came back. So one of the most famous lunar swirls is on the near side in the Oceanus Procellarum. It's called Rainer Gamma, and it's a very, very typical bright one. It's got a kind of this eye feature in the center, and then your swirly patterns that kind of go out away from it, catty corner, and you can see it through a telescope on the near side, and so it has been observed for hundreds of years, but nobody really thought anything other than, it was probably just impact crater ejecta. And it was near this other crater called Rainer. And then when we started getting the first, I think it was surveyor images that came back, somebody noticed that they were they were different. They weren't, it wasn't just typical ejecta because of these weird patterns.
So that is pretty neat. So it pretty much came down to us having something that got closer and could
Right.
take a better look.
Yeah.
So what kinds of equipment, what of various surveys and stuff do you use to discover all of this?
So in the portion of the spectrum that I work in, you can, so, okay, you know how like you know how you have red, green, and blue to make a color picture, right? So we can actually use red, green, and blue, but instead of assigning them to the wavelengths that they are really assigned to, which would be for red, it's like about 700 or something, and for am I getting that right? Yeah, right. And then for like green, it would be about I think 600, let's say, and then for blue, maybe like 450, 500. Instead, I'm going to assign the red, green, and blue to other wavelengths of light that have some geological interest. So for instance, on the moon, there's a phenomenon where if you look at the spectrum of all these different wavelengths and how much is reflecting back, if you look at like a bright area on the moon, that reflectance might look kind of bright, like it would be like reflecting back maybe 10, 15% of the sun's light that's hitting it. And it would be all maybe about kind of close to even across all the wavelengths. But as it matures, you start getting what we call reddening, which means that as the surface ages, the redder or more infrared or the longer wavelengths of light start increasing a little, and the shorter wavelengths of light start decreasing a little until you get to the ultraviolet, and then other things happen. But in just right there, so you can actually take the ratio of two different, like a place in the visible light and then maybe a place out in the middle of the near infrared, and use that ratio and plot it against just the albedo of one wavelength, and you will see, okay, so if they plot here, you're getting something this is demonstrating that it's maturing. So at the lunar swirls, they don't have this reddening like they should. So that's one way that I look at them. And in fact, in the ultraviolet, which behaves a little bit different in that it's just a shorter region, but instead of a reddening, there's a bluing as it gets older. And some work by Brett Denevy looking at the lunar swirl, and then also Amanda Hendricks, looking at the lunar swirls in ultraviolet light. I'm sorry, looking at the whole moon in ultraviolet light, they noticed that the lunar swirls were really the only thing that continues to look like it's fresh in the ultraviolet light. Like even fresh impact craters like Tycho or something, you just don't see those bright ejecta rays anymore. They all start looking about like the same, as if in ultraviolet light, everything will mature or age quicker, except for the swirls. They continue looking fresh.
Any idea why they might be doing that?
I think it's because of the magnetic anomalies are effectively keeping the solar wind protons from hitting the surface. So I actually hypothesized that this is demonstrating that the solar wind is the dominant form of space weathering compared to micrometeorites. These are basically the two agents that will darken the lunar surface significantly, or darken, any surface that doesn't have an atmosphere, or age the surface, age and darken. At least at the Earth-Moon distance, it looks like it's the solar wind that is the more aggressive one. So if you're blocking the solar wind, like the swirls are doing, then they're not aging. But still, micrometeorites get through because the magnetic field can't stop them.
So we've had some questions recently about lunar dust and how that might be a big problem whenever humans return to the moon. What kinds of things do you know about lunar dust, and what makes it different?
So it's very fine grained. It's basically like powder, really, is a better way to think about it. And if you imagine, like, you take some talcum powder and you haven't closed the cap and you like bang it down and it just goes up in the air. And of course, there's no atmosphere, so it doesn't hover there as much, but it does go everywhere. But there's a couple other properties that one can kind of be used to our advantage in that, especially the more mature soils, as they get older, they are micrometeorites, and even larger are actually fusing or melting and fusing these and creating we call them regolith, into little pieces of glass. And also during the process that involves micrometeorites and the solar wind coming in, there's a lot of iron oxide in, oh, sorry about that. I didn't turn my phone off. That was, do that real quick. Okay.
That's okay. I have a dog that'll go off in a little while. So.
Yeah, I know. I had to close the door for my dog. They saw a squirrel and it was mayhem.
Yeah.
The solar wind protons, as they come in, they will actually carry enough energy to break an iron and oxygen bond, and thereby release the oxygen to maybe go hang out with hydrogen or something and make water, who knows. But it will also leave behind iron. And now iron, instead of being in a 2+ state, it's in a 0 state. So you have made little tiny iron, metallic iron. And this process continues on. And the same thing with micrometeorites can do this by the fact that they come in with enough energy, and that can also drive them apart and melt and create glass. So you wind up getting, as the soil gets older and older, you get a greater accumulation of these little tiny metallic iron blobs. Now, they're not going to be magnetic of their own accord, but they are influenced by a magnet. So there is some work being done to move the lunar soil or manipulate it in some ways using magnets. So that could be to our advantage, to be able to use that to get it out of everything. The disadvantage part, though, is that because there's no atmosphere, and because of a lot of the crushing and creating of these broken fragments, you get chemically, if you can imagine, again, like this bond is breaking. If you have a mineral, especially on the moon, a lot of the minerals are silicates or oxides, and that means they have a lot of oxygen in them, which is great because we can get oxygen out of it, okay? But as a particle, a dust particle, it is just a fractured bond. And on Earth, where we have a lot of water in the atmosphere, water will ease the negative aspects. The negative aspects is a silly thing to say. The negative charge that is left over on those broken bonds, because oxygen will, when it breaks, it will leave a negative charge on the outside.
Right.
So we have water to neutralize that, but without a bunch of water in the atmosphere, you have these negatively charged bonds, and you basically have oxidants. So you inhale these particles, and I mean, not only are they sharp, but they also are chemically really dangerous. So that's the drawback. So we need to be able to manipulate them properly to make sure the humans are going to be okay.
So moon dust, bad on multiple levels.
Yeah, it's not something you want in your air.
No, that makes sense. Getting back to talking about water on the moon. So what methods do you use to find that, and what places do you typically find it? Is it predictable, or is it surprising you?
So the fact that we saw it all over the surface was a big surprise. And this was discovered virtually simultaneously, but it by 3 different instruments. But it did take their combined efforts, and there was 3 publications at one time, that because there was 3 different instruments that saw this feature, they could support each other and say, yeah, okay, this isn't just like one instrument that's got something bad going on. So it was the Moon Mineralogy Mapper, which was on Chandrayaan-1, and that was launched in 2008, and then the near-infrared camera on Cassini, and the deep impact, which became epoxy, and I'm sorry, I can't remember what epoxy stands for, but it carried also a near-infrared spectrometer, near to mid-infrared spectrometer. And this portion of the spectrum is important because there is a really big, huge, whopping absorption feature at about 3 microns, or 3,000 nanometers, that is due to molecular vibrations of H2O. And it's such a big, huge feature that it's why we can't look at these things with a telescope on Earth, because it's just taken all the light away in that particular region, and it's really a big feature. So if you're going to find any little tiny amounts of water, it's probably going to be in the 3 micron region. And the Cassini's camera and Deep Impact's camera, they had a wavelength range that could see either side of that 3 micron feature. So they were able to capture it well, but they were looking at only a few pixels to take up the whole moon. And they did see this a deeper absorption band in the polar kind of regions, but not like literally at the poles, but rather like close to the poles. And for the Moon Mineralogy Mapper, that had a much better spatial resolution because its whole point was to map the surface. And that was the instrument that that was able to really truly characterize how this feature was being created and destroyed with the day-night cycle. Even though both the Cassini, the Deep Impact instrument also saw this feature too, but again, it was looking at such a spatially not as good resolution. So it was a little bit, you couldn't characterize its behavior like with shadows on craters in certain areas, while the Moon Mineralogy Mapper could.
Well, are there any other things that you specifically like to share about whenever you present on these topics that you'd love to tell our audience?
I guess I would say that there's a website that I use every day, and it's if you did a search on quick map as one word, and moon, I think that would do it. That would take you to it. It is this tool. It's absolutely free to use. It's amazing, and it combines almost all of the data sets that have been remote sense data sets on the moon, and they overlay them as layers. And so you can look at all of these different data sets, and you can find out information about, say, like I want to look at this particular one region, and I want to see what kind of gravity data I can see there, and what kind of magnetic field data, and what kind of just black and white image data. And you can do that. When you first load the website, it loads the currently orbiting Lunar Reconnaissance Orbiter wide-angle camera data. And as you start zooming into a region, eventually you'll see that it's like you're zooming in, and then it'll almost look like it pixelates, or you start seeing these kind of stripes or strips, or they might not be the same shade. They might be a little offset. And the reason is because it's now switched to the narrow angle camera, which can get down to a 0.5 meter per pixel resolution. And this is the one that was able to like tell that the flag was still standing at some of the Apollo sites and such.
And it takes pictures in stripes, right? And so they reconstruct the mosaic with that. So that's one of the reasons you get the different colors.
Right. And with the narrow angle camera, it's like you get these different shades because they're taken with different illuminations of light, and it would take a ridiculous amount of processing to show them up on this particular website all proper. But the point is that I can easily just get lost zooming in and looking around at things. It's indescribable. It's just craters all the way down, and other just interesting features. So, and again, this is like what scientists actually use to do their science. They use this tool, and for really understanding imageries, you can take measurements with it. You can do your own citizen science kind of thing with it.
Which is a really cool thing, because generally any of this information that has been gathered by like government agencies gets put up on a public website like this, so all folks can do this. I know NASA does it. I'm pretty sure ESA does a lot of theirs, and so it's something that citizen scientists can find. And when we have our Moon Mappers program going back up, you'll be able to go back in and see stuff. I think maybe in the testing phase right now, but I'm producer, so we'll wait for what Pamela says. But yeah, we're getting to look at a lot of those LRO pictures of the surface of the moon too, and mapping the craters. So, and it's really interesting to see how how the images are different of the same location with the sun in different angles.
Right. Yeah, absolutely. Yeah. And you could also use this tool I actually use it pretty often to find out. So let me back up a little. So, NASA makes all of the data publicly available, right? All data from all missions, right? The problem is that if you are not somebody who has been spending their whole life studying, these planets, and maybe even more specifically studying the particular instruments, even, it can be really hard to use that data. It's just, it's just the data. You have to have the right tools to manipulate it. You have to know, what problems you might encounter, blah, blah, blah. It goes on and on and on. But the Quick Map tool and some of the other tools that NASA has put out make it easy for anybody to use. And I actually so I use Moon Mineralogy Mapper data a lot. And just to find out, okay, so Moon Mineralogy Mapper did also like strips of, orbiting the moon and gathering strips. And I want to make a mosaic of just like one region. And I want to know, okay, which of the M-Cube strips are going to cross that region. I go to Quick Map Tools to draw a box, and then I query it, what's the M-Cube data, and it gives me the list. And then I know, and I can go to the planetary data systems and get those M-Cube datas, and then I can do what I do with it. But, you don't even have to do that per se. Let's see, you know enough about the Moon Mineralogy Mapper to look at a reflectance spectrum and make some interpretations of that. You can use the point tool in Quick Map and say, okay, I'm going to place a dot right here. Give me back an M-Cube spectrum, and it will return the spectrum from that location. For anytime there's an M-Cubed strip that passed it, it'll show you each of them. And what's even cooler is that it will show you a picture of where you've placed the dot in using the Lunar Reconnaissance Orbiter camera data. And then it will show you where M-Cubed thinks that dot is, because sometimes the geometry doesn't really match up. It's very complicated to get those things to match up properly. So sometimes it'll be a little off, but this thing will show you like, okay, yeah, M-Cube thinks that where you put the dot is actually here. So the spectrum I'm giving you might not be in the exact location, but it gives you a sense of, okay, I need to move where I think it is to here just so I can get the right M-Cube spectrum.
It shows you kind of pretty well in the ballpark.
Yeah. Like, if like, for instance, like I wanted to get a spectrum of the tree behind you, and I put a dot on that tree, but really then it comes back and it shows, yeah, okay, so LROC thinks that it's on the tree, but M-Cube thinks that it's on the banister of your stairs. So then I'd know, okay, maybe I got to go a little up and to the left and put a dot there so I can get with the M-Cube spectrum in that where the tree is actually looks like.
So it basically helps you calibrate how much it might be off of what you're thinking you're putting there.
Right. Yeah.
Well, let me check real quick and see if we've got any questions in here from the chat for you about the moon stuff.
Okay.
And then we'll come back because I want to talk to you about superheroes of science.
Okay, great.
Okay. So let's see if we've got any moon questions real quick. I'm looking over. Okay. From Haney's Vorwerp, we have, how different is the moon's mineralogy than Earth's? And how can you tell it's related?
So that's a great question. One of the reasons I like to say that I like to study the moon, and back like, in 2007, I could say this entire thing. The moon is really easy because there's like 12 minerals and no water. Because water alters minerals and makes them into different minerals. And so on Earth, we have over 5,000 minerals. It's ridiculous. And if you throw water in, you can just get some crazy mineral structures, like chemical formulas. But on the moon, it's basically down to about 12 minerals, and they can't be altered. Now there's water on the moon. Well, as far as we know, they're still not really altered, but maybe it'll start happening. But so the difference mineralogically is we have all the same minerals on the moon. You can get the same minerals on Earth, but they are going to be chemically different a little. It's going to be more in the isotopes, how they're different. Actually, one cool thing is that there is a iron titanium. So an iron, the most popular iron titanium mineral on the moon is called ilmenite. On Earth, it's not it's kind of rare. Mm-hmm. And on the moon, it's not so rare, at least where there's Mare basalts. But there was another iron titanium oxide that obviously is chemically the same, but structurally is a little different, that was first discovered in Apollo 11 samples. And so they named that mineral for the first 3 astronauts. The mineral is called armalcolite.
Well, that's actually a pretty good combination given what really you could have ended up with. Yeah.
Later, it was found on Earth, but it was first discovered on the moon. So yeah, and chemically, the difference in these minerals is going to get down to the isotopes.
That makes a lot of sense. And it sounds like, if we were able to get there, and have a human presence there, we probably could find even more stuff because it's just simpler if you can kind of walk out and study it right then, and then be able to run back to the same place, take another sample if you need to.
Right. And again, there's the entire other side of the moon that, well, I mean, up until China landed there, nothing had been studied.
Right.
We had no idea what was going on there.
I'm trying to read it. There are a bunch of questions and they're jumping around, so let me scroll. Someone asked, how much water are we finding on the moon?
Oh, I really, really don't like to quantify it because it's so complicated.
Yeah, you can give it a lot, a little. It's everywhere. You can do that kind of thing.
So yeah, I mean, I would say that at some time of the day or night actually on the moon, it will be everywhere, and the reason I put quotes around it is because, so usually when you say water, people think liquid, right? So I say, it's not really liquid. Oh, then it's ice. Well, it's not really ice. I mean, if you're looking at like 15 molecules or something, or something that's like just like 3, 6 or whatever molecules deep, is that a solid? Is it a liquid? Is it a gas? It's a little hard to say, right? I'm not sure.
It's such a small amount. It's kind of hard to tell. Yeah.
Right. Yeah. And it's very difficult to quantify because we don't really have good constraints, calibration points to quantify it. We can make a lot of assumptions, and people have made assumptions and quantified it to some extent. And personally, I applaud their efforts. I don't see the point in it because it doesn't, it's just really, in the end, it's just a mystery. I mean, we'd have to go there. And even if we went there and measured this surface, I'm talking about this superficial, diurnal transient layer, which I call space dew, because it kind of comes and goes with the night cycle like dew, even though there's no atmosphere. It's not, anyway.
I remember you came on and talked about that on the weekly Space Hangout.
Yeah.
Yeah, that was a cool topic.
Yeah, some people really cringe when I say that because they say, "Oh, but there's no atmosphere. People are going to misunderstand." And
you're like, "That's why they have to watch and listen when you talk, so they know what you're talking about."
But so it's basically like protons come. At least my hypothesis, and I think other people also their hypothesis is that it's solar wind protons that might be interacting with some of those unsatisfied oxygens that are either in the surface, like maybe they've gone down a little bit, or maybe they're just hanging out at the surface, and it might not really be staying. It's not a proper bond. Mm-hmm. And you give it a little bit of heat and they just break up again.
Because they're just waiting for something to happen.
Exactly, yeah.
Yeah. Another question we had was, as far as going back to the moon, are there any particular experiments you would want them to be doing? And any particular kind of instruments you would want them to send if you were in charge of what to send?
So actually, I'm a big fan. So again, I love lunar swirls so much. So I would, if I could just have any mission, I guess it would be a rover in the end. But as the rover is descending, let me back this up. So as the satellite is orbiting, it releases a bunch of nanobots or CubeSats or something, and then also a larger rover. And these CubeSats are just magnetometers. And the point is for them to scatter them over a lunar swirl area, and for them to be taking measurements as each of them go down to the surface, because the three-dimensional shape of these magnetic anomalies is not known well. There's models for it because most of the data from the magnetic field data was taken up at about 100 kilometers. So then they have to do some inferences about what things look like. But we think probably the lunar swirl shapes are indicating how the magnetic fields look, but we're not sure. And on top of that, since it's not just simply magnetic fields that are blocking it, it's actually electric fields that are getting set up from that, things might get more complicated. So I would love to see a bunch of these magnetometers that could make a three-dimensional point cloud.
Yeah, just fly all the way through it and get your measurements all the way in there.
Descending, and yeah. And then the rover, I mean, it could be a lander, of course. Who wouldn't want a rover? And of course, who wouldn't want humans too? But okay, would be to land. If it's just a lander, it would be to land right at a swirl and what I call on swirl and off swirl location, which can be a pretty sharp boundary actually. And you could get measurements from a swirl and from a not a swirl location, and see what the chemistry, how they're chemically different, if there's any mineralogical differences, and how, you know, this whole like its maturity thing is working out, how it really plays out. I mean, and it's possible that at these swirl locations, the magnetic fields could actually be useful for deflecting charged radiation for habitation, for maybe electrical components or something, if you wanted to build a habitat there or something. That's a little bit hand wavy, but you know, it's something to look into. I'm not a geophysicist, so.
No, but that's pretty cool. Just getting right there on those boundaries and studying what makes it in the swirl and what makes it right outside of the swirl.
Right. Yeah, and actually it actually does sort of look like in some of the locations where, so, you know, again, you have these, it looks like protons are being deflected away. So they're going somewhere. So there are some places that look like they might actually have matured like really fast because maybe there was a lot of protons being thrown there. So getting to get a look at that might be good. Another thing actually, which I can't believe I forgot to mention this, was that with Moon Mineralogy Mapper data, we looked at this hydration feature, this 3 micron absorption at the lunar swirl locations. And everywhere there's a bright swirl pattern, there is a lack of water or hydroxyl. It is significantly stronger at what are called dark lanes, these areas where it looks like the protons were all kind of funneling onto it. So might be a good place where there's some scavengeable water sequestered. I don't know. It's hard for me to say that the solar with the space dew that's created really is useful for acquiring the water out of the soil. But I do think it might be a useful process for creating water.
Which would be vitally important if we're going to have a continuing presence on the moon.
Yeah.
Water is pretty critical and it's way too heavy to bring all of it from Earth. So yeah. Do these lunar swirls, do they have properties that you think that you would find on other planetary bodies that don't have atmospheres? You think you would find something similar?
So you kind of would think that. And actually, I failed to also mention that when these swirls were first identified as being weird, there was 2 hypotheses that came out somewhat simultaneously. And one was this solar wind deflection hypothesis. And the other one was that they are actually fresh impact craters from comets. And that basically the reason they have these kind of swirly patterns is because the coma of the comet, as it started hitting the moon, a temporary atmosphere is set up and swirling actually is happening to the soil. So some of the work that I did showed that these are not fresh features. They are definitely not actually fresh features. They are as ancient as at least the rest of the soil around them. And also the guy who came up with the comet impact hypothesis said that, you know, if this is the case, he predicted that on Mercury there should be a lot more lunar swirls, they'd be Mercury swirls. There'd be a lot more swirls,
right?
Because Mercury sees a lot more impacts, comet impacts. And as soon as Messenger started returning data that was sufficient to look for them, none were found. Absolutely none. When Dawn went out to Vesta, this was also another candidate for having swirls. It's got no atmosphere. It's a generally basaltic composition. No swirls could be identified, nothing that looked like them. So I think that still kind of fits with the idea that it's at the Earth-Moon distance where the solar wind is the dominant force for maturing a surface. It could be that out at the asteroid belt, micrometeorites take over as the dominating force. It could be at Mercury. Well, it's got a really complicated magnetic field that could be making it really hard for any swirls to be created in the first place, or rather not be created, but rather there could be surfaces that would be protected since it's got like a global magnetic field. There's isolated locations where the magnetic field kind of bends in on itself and the solar wind could get through. But they're isolated regions, and those places aren't showing evidence of swirls either.
So that's pretty cool that it seems to be somewhat unique to our moon, at least, as far as we know. We have not yet been able to get close enough to another planetary body that has a moon like ours to see, but maybe we'll. And you'll see something similar, and then you'll realize, yeah, it does have something to do with the Earth-Moon distance and the relative size and all of those.
Right. I mean, if like Phobos or Deimos showed evidence of swirls, then that would kind of blow my hypothesis out the window, because the solar wind would be significantly decreased out there.
Right.
I think, but I don't know.
Let me look real quick and see. I know I saw some more questions going by. They go by quick. Could the magnetic swirls pose any problems to a spacecraft landing within them? That's a good one.
It is a good one, and I'm not really qualified to answer that.
It would need more study, probably.
It probably would, right?
Okay, let's see. Oh, they jump so fast. Was there anything from the Apollo missions that they found that you're directly applying to this? Since we're in an anniversary year for that.
Right. I believe it would be, I think it was Apollo 15 and 17, I believe, that had magnetic field data. It was isolated, but it did go over Rainer gamma. So I don't actually do anything with the magnetic field data other than thank the people that make these maps and then use the maps to just kind of correlate, like, how this looks in the spectral data. But yeah, I do believe I think it was Apollo 15 and 17 that had magnetic field data that was useful.
That's pretty cool. And yeah, it's probably the newer instruments that are better able to give you the information you need to work with. But we thank all of them for all of the mapping work they've done and all of the groundwork they laid for everything we've discovered since then.
It's interesting. Apollo 16, they went pretty close to a couple of swirls. They're very small swirls. And that was a highland region too. So there's swirls that they were maybe initially hard to identify as such, because something that's bright on top of something that's bright can be hard to see. But there's no evidence that they sampled anything from them. And it's not like these swirls were within walking range or something, but or roving range, but they were the closest that we got.
So there's not some sample sitting there and sealed up that you're like, I wish I could get to that just to see.
I don't think so. I mean, yeah, I think so.
But hopefully, we make it back this time. Maybe they'll be able to get some stuff for you. So that would be very cool.
Mm-hmm.
So you could see exactly what it looks like. Well, you have told us a lot about the moon, but that is not nearly the only interesting thing about you. Why don't you tell us a little bit about one of your favorite hobbies, being a superhero?
Yeah, I like to. One of my favorite hobbies is making costumes and stuffed animals.
Are those yours behind you? Did you make them?
Actually, it's only Cthulhu that I made, really. I call
it. My Cthulhu's in the other room. I should have gotten it. I have a little one.
I read, like, when I was first discovered Lovecraft after reading The Call of Cthulhu, it was like I was possessed, really. I had to make this. It was weird. But anyway, so I like, I guess cosplay, although I don't really go to cosplay events as much as I probably like to, but I did have a friend who used to volunteer, and he used to do the science, what he called science faction part of Comic Palooza. And he had invited me to give a presentation there and be on a panel. And so I had done that once. And then the next year I said, hey, what if my friends and I took on superhero personas and came as these actual superheroes of the science that we do. And he liked the idea. And so the female superheroes of science were born. And then our point is to be like an inspiration to girls and boys. But we like to, of course, flaunt our feminine abilities to be scientists and engineers. And so I am the lunatic phenomenon. We've had the Marvelous Martian is one of us, and Comet Girl. And actually, I believe it will be Comet Girl, Volta, and Anvil Girl, and myself, who I think we're going to be doing the 11 o'clock Central Hour tomorrow.
Oh, that's pretty awesome. We're going to
Yeah.
be definitely looking forward to that. And it's really awesome to have people that are good science communicators who are also dressed up in the fun with everybody too. Because go ahead.
Oh, we've done other events besides Comic Palooza. We've done we've go to schools that have like if they have a space day, or just they want superheroes to come. There's a event called We Are Girls, which is in Houston every year. It's done by the Girls Empowerment Network, and it's like a bunch of different workshops, and we do an event there that people sign up for, and in that event it's about an hour long for each of the workshops, and we talk about how we got where we are, why we decided to become scientists, and what our superpower is. And we each have our own like superhero symbol, and so we tell the girls to think about what their superpower is, what they want to do and use to make the world a better place, and to draw their superpower symbol. And so that's what we do.
That's a pretty awesome thing. I think you guys maybe should look into creating chapters everywhere, because
I really want that. Actually, we did finally start a Facebook page. It's small, and I beg you to go out there and like us, because we need likes, I suppose. If you look for the Female Superheroes of Science, I'm sure you'll see us. And we ask you to join if you are interested. You don't have to be an active professional scientist. You could just want it.
You can be science adjacent like me.
Yeah, exactly. Everybody is a scientist, actually. I don't care what your profession is. I can tell you how it's a science.
Yep. If you're doing stuff and you're writing it down, you're doing science. Yes. There you go. That's pretty cool. But yeah, I mean, this is definitely the kind of thing that we need more of, because we need more people out there, critically thinking and realizing that science is interesting and fun. And with the rise of STEM focus and education and stuff, it's a great time to go in and show that scientists aren't all buttoned up serious people all the time, that you can have a really great time.
Yeah, doing all of yourself. You can be real and you can have fun.
And for those of you who know Dr. Pamela, she often does cosplay as well and goes to DragonCon regularly and does stuff. So this is actually pretty common for a lot of scientists to kind of dress up and go do things. So if you're going to conventions and things nearby where you live, you can probably find some scientists there doing something kind of fun, maybe a little goofy, but that makes it even more fun.
That's right. Yeah, they might be disguised as a Wookiee or a Klingon. You can never tell, but there's probably a bunch of scientists there.
A bunch of folks in there doing stuff. And I had another question and now I can't remember it. So let me look and see if folks have more questions in the chat. I got scolded. I need to mention more people's names when I ask the questions. So yeah. See, usually I'm the one on the other side, not the one talking. Now I'm realizing just how hard this is. You guys, y'all should have major respect for Pamela and Annie for sure. Let's see. Where was that? I don't write anything down, so I'm screwing around all the time. That's Bill Nash saying that. Yeah, write it down and then it's science, okay? That's what makes
I would say thinking is pretty close, but you got to write it down if you want other people to
keep it. Because I do a lot of the thinking, but not a lot of the keeping. Sometimes I get busy. All right, let's see. Oh, I was going to also tell you if the superheroes of science wanted to show up on our Twitch stream sometime, you know where we are because you're part of the Planetary Science Institute. So we're here to help you as well. And you guys viewing, if y'all want to see some of these folks show up, let us know. Definitely support us. And we can start recruiting more folks to come on and do really cool things.
That would be fun.
Yeah, it's a lot of fun, and it's a great way to get the information out. And there's a lot of combination, because there's a lot of cosplayers that do stuff on Twitch and a lot of scientists that do stuff. So it's a good meeting of the minds. All right, let's see. Currently, there is a giveaway for a Star Wars adventure comic. If you haven't entered that one, go ahead. And let me look and see one more time if there's any others. I may be able to go back and grab a couple of the moon questions too. Is there anything else that you particularly like to share when you're out talking to folks? Something I didn't think.
Like I have, all the time, or like everything I could talk about, unless I can be able to like start showing pictures, I could like,
We would love to actually have you come on and do the pictures and stuff too at some point, or at least I would. I enjoy looking at the pictures and knowing the differences between stuff. What's your favorite spot on the moon to look at? Just of a specific spot, not just a lunar swirl.
Oh, that's really hard. Wait, so it can't be a lunar swirl?
It can't be just lunar swirls in general, but like if you have a specific one that you love to go back and look at.
So the first swirl that I ever mapped and like wrote about and published about was it's called Mare Ingenii, and it's on the far side. It's actually in South Polakian Basin, and it's the one place that, I mean, if somebody was to say like, George, you get to pick the next location that we land at, it would be Mare Ingenii, because we would not only be hitting a swirl location, we'd be hitting a location that's in South Polakian, so we could get South Polakian samples. We could potentially be getting South Polakian samples that haven't been altered by the solar wind.
That's
since
cool.
For like 3 billion years or something. And it also crosses Mare and highland material too, all the swirls there. And there's also some strange, it's called the furrowed terrain, that's kind of north, but somewhat surrounding the Mare Ingenii region. And it's thought to maybe be related to the Imbrium impact, because this is just on the opposite side of the Imbrium impact. That's the really large impact on the near side. So for me, when I look at the moon, I see the squirrel feeding the poodle when I see the full moon. So it would be the squirrel's head.
Okay.
It's a big squirrel or a little poodle. Anyway,
I don't think I've ever seen the squirrel and the poodle, but now I'm going to go Google it.
I challenge you to not see it now. Yeah. Okay.
I've seen the rabbit, and I've seen the cat playing with a ball, but I don't think I've ever seen the squirrel. So and the poodle. I'll have to look for that one.
I can't believe I don't have a picture of the moon here.
You're like, where did my moon picture go?
Surely I have. Oh no, that's just not going to work.
That's cool.
No, you can't tell. Never mind. Sorry. So anyway, but yeah, Mare Ingenii is on the far side anyway. So, but it's opposite Mare Imbrium, and so it could be that the impact basin itself did something weird on the antipode to the terrain. That's hypothesized. That's a neat location. And then it's another swirl location, I guess, is Mare Marginis, which is on the eastern limb of the moon, and there's a fresh impact crater right above the Mare that hit the highland area, and it looks like the swirls emanate out of it, which is kind of the impact for it being a comet impact. But really, I think it's just got to do with the fact that it threw all this bright ejecta everywhere. There was already magnetic fields there, and that ejecta doesn't darken wherever the magnetic field protected it. But it's very pretty. I'm trying to think of a non-Mare. Okay, yeah, Aristarchus is an impact crater also on the near side, and that is associated with some of the youngest Mare basalt flows that have been identified, maybe as young as 1.7 or 8 billion years, so just yesterday, pretty much. And it also has radon has been detected coming out of it by a couple different spacecraft, and it just has some really interesting features, some volcanic looking features, although Aristarchus itself is definitely an impact crater. There are some associated volcanic features, and what ejected out of Imbrium is strange looking. A little, I mean, they're rocks, okay, but some of them look like they're striped black and white.
Oh, that's interesting.
Yeah.
It sounds like the moon is a lot more fascinating when you get up close and start looking at it than you might expect. A lot of people think of it's just kind of a dust ball that doesn't have a lot going on, but it really has a lot.
It really gets me. I mean, I tell people go out to look at the lunar quick map and just start zooming in. It doesn't matter where, just zoom in, and it gets just cooler and cooler.
And so that
layers and
yeah. So what's that website again? Lunar Quick Map. Basically, Google for that.
Google Lunar Quick Map, you'll find it. I can't really think of the website off the top of my head, but Lunar Quick Map will do it, I'm sure.
Right. Oh, Keeper of Maps had a question. Radon suggests other radioactive minerals, right?
Yeah. So actually, it is known that it's on the near side of the moon there is this giant hotspot. If you look at thorium data, that just stands out as, we call it a hotspot because I mean it's not like hot. Like if you go there, it's going to be hot because the astronauts do go. But relative to the rest of the moon, it is rich in thorium, uranium, and other radioactive minerals, potassium. And in fact, it's enriched in potassium, rare earth elements, and phosphorus. So it gets the acronym CREEP, KREEP. It's thought to be the leftovers after the moon differentiated into a core and mantle and crust. All of the elements that didn't want to go into those 12 minerals just kind of got like left behind, float just underneath the crust of the moon. And along comes Imbrium and these other big impacts, and they throw that stuff out and over, and you get this creep exposed to the surface.
No, cool. That's pretty cool. Yeah. There's so much of a story in the way that the things are laid out. And it's almost like a forensic investigation, going back and figuring out where these could have been before and what pulled them out and how did they get there.
Yeah. So if any of you online are going to go to Lunar Quick Map, go like when you first load it, it's going to do a orthographic projection of the near side of the moon. You'll see on the left side, you can get different layers. Go to Lunar Prospector and go to the thorium and turn and highlight that one, make the thorium come on, and then you'll see that hotspot, that creep hotspot.
That's pretty cool. So I think at this point, let me check and see, do we have any last questions? If you guys have any more moon questions, feel free to put them in there. Larry Weird says, ooh, the moon is perfect for fission then.
There's for other reasons, some people think it is actually, but it's not because of that.
Not because of that. Let's see. Okay, and Paranor, thank you for putting in the link to Lunar Quick Map. He's got that in the chat for everybody.
Oh, thanks.
Our mods are great. Just I'm not usually on talking, so let me just say how fantastic our moderators are. They do a wonderful job. They make it where it's warm and friendly when we're in here talking, and we can pay attention to talking to guests instead of worrying about what's going on in chat. So, well, all right. I think, George, at this point, we'll let you go. You have been wonderful to talk with us for an hour.
Wonderful. This has been fun.
And we're very excited. You'll be back tomorrow.
In costume.
In costume. So that will be fun. And we'll make sure Pamela gets additional pictures as well, so we can post on all our socials and stuff. So we can talk about, look at the superheroes that came to our hangout-a-thon. But thank you once again for being here. And I'll see you at PSI stuff. So okay. I'm excited about that. And I think if the crew back at headquarters over there is almost ready, I think they're going to show you a couple minutes of dog video just to give us a little break.
I'll stick around then.
Yeah. And then I've got Alan Versfeld, who is one of our astro journalists. He's going to come on. He is going to talk to me. I need to go look at the list and see what he's going to talk to me about. But we'll be back here in just a few minutes. So
thank you. Bye.
Thank you. Bye-bye, George.